All right, if you guys have your specific heat capacity problems in front of you, we're going to go through number 1 and we're going to go through number 5 together. So what I like to do is I like to start by outlining all of my variables off to the side. So as I start reading through this, what is the change in enthalpy? Enthalpy, remember, is Q, so I'm going to put a question mark there. In calories, when 100 grams of ice, so I know that my mass is 100 grams, is heated for negative 18.2 degrees Celsius to negative 7.2 degrees Celsius, so that'll give me my delta T. Delta T, or change in temperature, is T final minus T initial. So this is my final temp, this is my initial. So I'm going to take negative 7.2 minus negative 18.2, and when I do that, I get 11 degrees Celsius. So to figure out C, I know that I'm looking for calories, and I'm looking for ice. So I'm going to go into the row that has ice, and into the column that has calories, not joules. So we're going to go right here, 0.496, and that's going to be calories, gram, degrees Celsius. Okay, now what I need to do is I just need to plug these values in. So Q is equal to Cm times delta T. So I'm going to go 0.496. I'm not going to put units on them because I already did over there. Times 100 grams times 11 degrees Celsius. That, when I put that in my calculator, 0.496 times 100 times 11 degrees Celsius, I end up with 545.6, and then it's again asking me how many calories. So that would be that many calories. So 545.6 calories would be the correct answer to number 1. All right, the second question that we're going to do is a little bit different, so I'm going to go to number 5. Number 5 says, what will the final temperature be of a 50-gram piece of iron if it absorbs 1,500 joules during heating if the initial temperature is 21 degrees Celsius? So just like I did last time, I want to outline my variables. So Q, C, M, delta T. This time it says, what is the final temperature? I have an initial, but I don't have a change, so I'm actually looking for the change in temperature this time. My mass, it already told me, was 50 grams. When I look at Q, which is the amount of energy that went into it, it's 1,500 joules. And then C, I know that I'm working with iron, and I know that my Q is in joules, so I don't need this one about calories. So I'm going to end up with 0.449, and that would be J per G degrees Celsius. All right, so now I'm going to take this equation and I'm going to rearrange it. So I'm going to be solving for delta T instead. So to get delta T by itself, if I have C and M on this side and they're being multiplied, I'm going to divide by C and M, divide by C and M. So what I end up with is Q divided by CM equals delta T. So now if I go and I do this, I'm going to plug in my values. 1,500 joules divided by 0.449, and again, that's joules per gram times degrees Celsius. I'm lazy, I'm not going to write that. Times 50 grams. And when I go through and I do that, I end up with 66.8 degrees Celsius. So that's part of the battle, but we're not done yet. All right, so we know right now that our change in temperature, delta T, from that previous slide is 66.8 degrees, wow, that's a really bad 8, degrees Celsius. I also know that the change in temperature is equal to the final temperature minus the initial temperature. And I know that the initial temperature is 21 degrees Celsius. So if I take 66.8 degrees Celsius equals T final minus 21 degrees Celsius. I need to get this 21 on the other side so that T final is by itself. If I'm subtracting it to get it to the other side, I'm going to add it, 21. So those cancel, plus 21. And when I do that, T final is going to be equal to 87.8 degrees Celsius. So you're going to have to manipulate that specific heat capacity equation every once in a while, and if you need to find T final, you have to first find the change in temperature and then solve. So if you have any questions, let us know. Otherwise, have a great day.